Section 4.1 Antiderivatives and Indefinite Integration. In Chapter 4 and 5, we will study about inverse operation of derivative called antiderivative or indefinite integration. As you can guess from the word antiderivative, given a function, you will find the antiderivative of it. So let's start. Antiderivative. A function capital F is an antiderivative of small f if capital F prime of x is equal to small f of x. So we're going to use capital F to denote it is antiderivative of a given function small f. Okay, now consider the derivative of each function. So look at what's going on in here. Capital F1 of x is x to the fifth plus 2. Capital F2 of x equal x to the fifth minus 7. Capital F of 3x equal x to the fifth plus pi. Out of these three different functions, when I take the derivative of the first one, what I'm gonna get is 5x to the fourth power. From the second function, when you take the derivative, yes, since derivative of constant is 0, I'm still gonna get 5x to the fourth. Third function as well, if I take the derivative of that, I get 5x to the fourth. So, what is the antiderivative of 5x to the fourth? Is it these three? So you can see these means capital F of 1, capital F of 2, capital F of 3 are all antiderivatives of small f of x, which is 5x to the fourth. Not only that, capital F of x could be antiderivatives of any x to the fifth power plus any constant c. So, for any given function f of x, its antiderivative is not a unique function, but instead you get a family of functions in the form of capital F of x plus any constant c. So when you take the antiderivative, you're gonna always have to attach this c, and that c means any constant out there. So family of antiderivatives, if capital F is an antiderivative of f, then all the antiderivatives of small f will have the form of capital F of x plus c. Make sense? Also, look at the graphs below. Let's say that the red color graph is a capital F of x. Then all other blue graphs are just vertical translations of capital F of x, which means all of them are only differ by their constant, but they have the exactly same shape everywhere, and in fact, their rate of change at any x, or the slope of tangent line at any point x, would be the same. So again, you can see that given a function, its antiderivative is not a unique function. Instead, you get a family of a function in the form of capital F of x plus c. Don't forget the c. Indefinite integrals, which is same as antiderivatives. So whether problems say to find the antiderivative or find the indefinite integral of this function, they are saying the same thing. The inverse operation of differentiation is antidifferentiation, or it's also called indefinite integration. So if d dx of capital F of x is small f of x, which means derivative of capital F of x, let's say, is the small f of x, then this is the notation of antiderivative symbol. We call it integral. So integral of f of x dx is equal to the antiderivative capital F of x plus any constant c. So if we explain these parts of integral, I just said this is integral symbol, and what you are taking integral is called integrand. and the dx is a variable of integration. So looking at that dx, we know we're taking integral of f of x with respect to x. And then what you're getting is capital F of x, and of course that is your antiderivative of your integrand f of x, and the c will be the constant of integration, which implies any kind of constant out there. Now, derivative of an integral. So you can see that integration and differentiations are inverse operations. They undo each other. So what that means is that if you take integral of a function and then take the derivative again, then you're just gonna get back to where you started with, because you just did inverse operations to each other, which undo each other, so that you just get back to original function that you started with, which is g of x. To see this more precisely, it says show that derivative of integral of g of x dx is g of x. So let capital G of x be antiderivative of g of x. So then when I take the integral of small g of x, I'm gonna leave d dx outside. I'm just only gonna do the integral part. So integral of g of x dx, since my antiderivative is capital G of x, I'll get capital G of x plus any constant c. The result of indefinite integral will always have a function plus constant c. And now, again, we're gonna take the derivative of capital G of x, and since capital G of x is an antiderivative of small g of x, when I take the derivative, I get back to small g of x, and derivative of a constant is 0, so that's all I'm gonna get, which was asking me to show. And we just show that if you take integral of g and take the derivative of that again, you will get original function that you started with. So for example, what's the derivative of integral of this function dx? Then there's no brainer, right? You're going to take the integral and then take the derivative again. We just showed that then you get what the integrand was. So you're just going to get the integrand, which is the square root of sine x to the third power. Just like there are rules for derivatives, there are basic rules for indefinite integrals as well. The first one is called the power rule, and we had a power rule for derivatives as well. Recall when we take the derivative of x to the power n, then n drops down to the front, and we lost one power. Yes? Now we're trying to going backwards. So going backwards, you can see that I need to gain one power. Whatever the current power I have, I need to add one power to go back. So rule for integral of a power function, integral x to the p dx, you can see I gain one power from existing power. So it becomes x to the p plus 1 power. Make sense? Not only that, now go back to d dx of x to the n equal n times x to the n minus 1 power. To go back, I need to get rid of this number. And this number n is one bigger than the current power. So to get rid of that, I need to divide by whatever current power, add 1, that will give me n, which n cancel then, and gain 1 power, I can recover x to the n. That's why it was dividing by the current power plus 1. So integral of x to the p dx equal x to the p plus 1 divided by p plus 1 plus, of course, the constant of integration, which is c. So integral of x to the p dx equal x to the p plus 1 power divided by p plus 1 plus constant of integration c. Second rule, constant multiple rule. If a constant multiple is multiplied to function f of x dx as an integrand, then you can actually pull out that constant and then take the integral and multiply by that constant later. Now, this c is not equal to the constant of integration. Not only that, when we distribute this c to the result of integral, we do not multiply this c to the constant of integration c, since all real numbers times a constant gives you all real numbers anyways. Lastly, sum/difference rule. Integral of f of x plus minus g of x dx equal, if you are taking integral of sum or differences of functions, you can just take the integral of each functions. And this was the same as rules for derivatives. So for example, evaluate each integral. I have right now integral of x to the power 1 dx. So what I have to use is the power rule. My power is 1 right now. So what do? You're gonna add 1 power and divide by that number plus c. What's the integral of t dt? So we're taking integral with respect to t. So this is t to the first power, so it's the same as the first problem. So what I'm gonna get is t to the second power now, but I gotta divide by 2 plus constant of integration c. The third one, what's the integral of x to the second power? That will be, I gotta gain 1 power, so x to the third power divided by that number plus c. Integral of 1 dx. If you don't have anything, it's not 0. It is actually 1. Okay? And what do you have to take the derivative so you would get 1? Yes. If you take the derivative of x, you get 1. But again, it's not just x. X plus any number, you take the derivative, you will get 1. So it will be x plus c. Let's keep going. What will be integral of 1 over x to the power 4 dx? Well, we didn't learn any other rule. We only have 3 rules so far. So you're just going to have to change this to a power. So that will be x to the negative 4 power dx, which is equal to then. So what do? Add 1 power to that. So I'm going to get x to the negative 3rd power divided by the number, add c. But then since that is negative exponent, we would rewrite the answer as negative 1 over 3x to the 3rd plus c. What about integral of square root of s ds? Again, yes, you want to change it to the power. So that will be s to the 1/2 power ds. So we're taking integral of s to the 1/2 power with respect to s. So if I add 1 power, what is 1/2 power plus 1? That will be s to the 3 over 2 power divided by 3 over 2 plus c. But dividing by fraction is the same as multiplying by reciprocal. So whenever my power is a fraction, then instead of dividing by fraction, multiply by reciprocal, which is 2/3 of s to the 3 over 2 plus c. Integral of 3 times the theta to the 5th power d theta equal, this is constant times function. So I'm going to pull out my constant multiple 3 out of my integral. And I have a theta to the 5th power d theta, which is equal to 3 times. Now I take the integral of theta to the 5th power d theta. So I'm going to gain 1 power, which is theta to the 6th power, divide by that power 6 plus constant of integration c. But 3 and 6 cancel. So my final answer will be theta to the 6th power over 2 plus c. What would be integral of 3t squared plus 5t plus 4 dt? We learned that sum or differences of a function, we could just take the integral of each term. So let's take the integral of 3t squared dt plus integral of 5t dt plus integral of 4 dt. And then that's the same as 3 times the integral of t squared dt plus 5 times the integral of t dt plus 4 times the integral of 1 dt. Then this is equal to 3 times. My t is gonna gain 1 power, so it becomes t to the third power divided by that power plus 5 times t to the gain 1 power, so it becomes power 2 divided by that power plus 4 times integral of 1 dt. Well, you have to take the derivative so that you get 1. That was t. And then even though you have a 3 terms, you took the integral, you still add only one constant c, because c1 plus c2 plus c3 still is a c. So we only need one c. Now 3's get canceled. My final answer then is t to the third plus 5 over 2t squared plus 4t plus c. All right, lastly, what would be integral of x minus 1 over radical x dx? Well, this is equal to x minus 1 over x to the 1/2 power dx. And x to the 1/2 power is the common denominator for both, x minus 1. So I can actually split this. So this is equal to x over x to the 1/2 power dx minus 1 over x to the 1/2 power dx. And since x have the same base, and when you have a quotient of two expressions of the same base, you could subtract exponents. So this will be actually x to the 1/2 power dx minus, I want to rewrite this as a power, so that will be x to the negative 1/2 power dx. So then I'm gonna add 1 power to the 1/2 power, which is 3 over 2. Again, when you divide by 3 over 2, it's the same as multiplying by reciprocal. So I get 2/3 x to the 3 over 2 minus, when you add 1 to the negative 1/2 power, you get positive 1/2 power. And when you divide by positive 1/2, which is the same as multiplying by reciprocal, which is 2. And I need to add the constant of integration c. So here is my answer for that one. As you have seen it so far, differentiation and integrations are inverse operations to each other. And because you know all the rules for derivatives for trig functions, you can actually answer all these integrations for trig functions. So what will be integral of cosine x dx? Since derivative of sine is cosine x, when you take the integral of cosine x, you get sine x, but you gotta add with the constant c, because when you take the derivative of sine x plus any constant, you get the cosine x. Now, since derivative of cosine is negative sine, integral of sine x will be negative cosine x plus c. And derivative of tangent is secant square. We don't know integral of secant, but we do know integral of secant square. And that will be tangent x plus c. And derivative of cotangent x is negative cosecant square x. So integral of cosecant square x will be negative cotangent x plus c. And derivative of secant x is secant x tangent x. So integral of secant x tangent x is the secant x plus c. And derivative of cosecant x is negative cosecant x cotangent x. So integral of cosecant x cotangent x dx is negative cosecant x plus c. So let's evaluate each integral. What's the integral of 5 minus 3 sine theta? So I can take integral of each term. I can take integral of 5 d theta minus, it's an integral of 3 sine theta, but 3 is constant multiple, so I can pull out in the front. and have a sine theta d theta. Now that 5 can be pulled out in the front too, but it's okay. What do you have to take the derivative? Then you get 5. That will be 5 theta. And then minus 3, and now times, take the integral of sine theta d theta. What was the integral of sine x dx? That was negative cosine x plus c. So I'm gonna get negative cosine theta plus c. So my final answer is 5 theta plus 3 cosine theta plus c. Next problem. Integral of sine x over 1 minus sine square x dx. Whoa, we didn't learn anything like that, how to take the integral of, right? So this is not something we can do it right away. We need to do some substitution here. What is 1 minus sine square theta though? 1 minus sine square theta is cosine square theta, right? I'm gonna rewrite this as sine x over cosine square x dx. And then I can split this as cosine square x is cosine x times cosine x. So one cosine x I'm gonna use for denominator for sine x. So I can have a sine x and cosine x. And then another one, I will just have a 1 over cosine x. And you can see if you just multiply these two expressions, you get back to sine x over cosine square x. But now my first expression, sine x over cosine x, is tangent x. And 1 over cosine x is secant x. And what do you have to take the derivative so that you get secant tangent? Yes, that's a secant x. So my answer will be secant x plus c. Now, we can also solve a differential equation with initial conditions. So what does that mean? Solving a differential equation means that given f prime, you are trying to get f. Given an f prime, when you try to get original f function, then my original f function will not be unique. It will give me family of functions with a constant of integration c. So that's why it gives you this initial condition. If you plug 5 into your original function, you should get 2000. And this initial condition will give you a specific c, so you can get the specific f. And also, you can given a f double prime. If you look at the second problem, when you take the integral of f double prime, then you are gonna get a f prime, right? But your f prime will have a constant of integration c, so they give you initial condition for f prime, so you can get the constant of integration value. So now you have a specific f prime, so that you can integrate that to get f. But when you get the f, again, you're gonna get a constant c as a general solution. So you can plug 0 in there to get what the c is. So you can have specific f function. And that's called solving a differential equation. It's actually pretty easy. So let's try to do this. Solve the differential equation. F prime of x equal 3x to the 4th power plus 2x. So I'm trying to solve for f of x. And to get f of x, I need to take the integral of 3x to the 4th power plus 2x dx. All right, now that we know we can take the integral of this each, let's go ahead and just take the integral of each without splitting them. So now when I take the integral of 3x to the 4th power, 3 is constant multiple, so it can be multiplied in the front. Now my x to the 4th will gain a power, so it becomes x to the 5th divided by that power, plus 2 will be multiplied in the front, and then x will gain 1 power, so become power 2 divided by that power, and then I need to add with the constant c. When I clean it up, it is 3/5 x to the 5th plus x squared plus c. So I got general solution for my f of x. But now my initial condition f of 5 will give me what the c has to be. So I can give particular solution for my f of x. So let's plug 5. F of 5 is equal to 3/5 times 5 to the power 5 plus 5 squared plus c. And they said that is value 2000, right? That's given. 5, one of them cancels, so this become power 4. And when you calculate this, you get 1900 plus c equal to 1000. So you can see that c is 100. So I just solved my f of x, and my f of x is 3/5 x to the 5th plus x squared, and my c is 100. So I got a particular solution. Solve the differential equation when f double prime x equal 1 plus cosine x. F of prime of 0 is 4. F of 0 is negative 5. Okay, so I should get f of prime of x first. And I can get that by integrating f double prime of x, which is 1 plus cosine x dx. And when you integrate 1 respect to x, you get x. And integral of cosine x is sine x. And then I will have constant of integration c. But they said f of prime of 0 is 4. So f of prime of 0, which is 0 plus sine 0 plus c, they said is 4. But sine 0 is 0 as well. So I have 0 plus c equal 4. So this c must be 4. So I found my f of prime. And my f of prime of x is equal to then right here. And we plug 4. So it will be x plus sine x plus 4. So now, given that, I would like to recover f. So f will be recovered by taking integral of f prime of x, which is x plus sine x plus 4 dx. And when you take integral of x, it is power 1 right now. So when you add 1 power, you get power 2, and you need to divide by that power. And integral of sine x is negative cosine x. And then integral of 4 is 4x. And then I will have a constant of integration c. However, they told me that f of 0 is negative 5. So I can plug 0 for x. So f of 0 is 0 squared over 2 minus cosine of 0 plus 4 times 0 plus c, which is equal to, I get 0. Cosine of 0 is 1, so you get negative 1. This is 0. Plus c has to be equal to, they said, negative 5. So c must be negative 4. So finally, my f of x is equal to, it is right here, and I need to just plug c in there. So that will be x squared over 2 minus cosine x plus 4x, and my c is negative 4. So you found your f of x. So you solved this differential equation. In chapter 3, we learned that there is a position function s of t, and when you take the first derivative of s, you get velocity function, and when you take the derivative again, we get acceleration function. So acceleration function is the second derivative of position function. Yes. So now, given acceleration, we can recover position function. And that will be same as solving a differential equation as far as they gave us initial values. So let's do this problem. It's the same as what we just did. An object is shot upward with an initial velocity of 64 feet per second from an initial height of 80 feet. Use a sub t equal negative 32 feet per second square. Find the velocity function v sub t. And since a sub t is the second derivative of a position function and velocity function is the first derivative of a position function, you can recover velocity function by taking integral of a sub t dt, because our variable is t now, and that's equal to integral of negative 32 dt. And what do you have to take the derivative so that you get negative 32? So then antiderivative will be negative 32t plus c, right? But what was the initial velocity? Initial velocity will be velocity at time 0. Is that right? So when they say initial velocity of 64, they're telling you is what then? Your v sub 0 is 64 feet per second is what they're telling you. So now I'm going to use that information to find my c. So v sub 0 is negative 32 times 0 plus c. They told you that it is 64. So this is 0, so c is 64. Then your velocity function that you are looking for is, it was right here, and I found the c. So that will be negative 32t plus 64. So you found your velocity function. And they said also find the position function. So now, since velocity function is the derivative of a position function, you can take the integral of velocity function to recover s sub t. So if we do that, then the position function s sub t will be equal to integral of v sub t dt, and my v sub t is negative 32t plus 64 dt. So when you take integral of that, negative 32t is negative 32 times, we're going to gain one power, so it becomes t to the second power divided by that power plus 64t plus constant of integration c. So these cancel, so I get negative 16t squared plus 64t plus c. And they also said initial height was 80 feet. And initial height, of course, is what? Yes, that will be s sub 0. At time 0, object was 80 feet high. So now you can plug 0 for t to find out what the c is. So that will be negative 16 times 0 squared plus 64 times 0 plus c. And they said that is 80. So this is 0. You can see that c equal 80. So your s sub t is, this was s sub t right here. And I just have to plug this c in there. So negative 16t squared plus 64t plus 80. And you found your s sub t as well. Okay, find the velocity of an object when it hits the ground. Well, we already have a velocity function right here, so I have to find out when. And I want the t that object hits the ground. When object hits the ground, what happens? Position is 0 because your object is on the ground. It's on the floor, so height is 0, correct? Okay, so that means s sub t is 0. So set that equal to 0. My s sub t is negative 16t squared plus 64t plus 80 has to be equal to 0. And then I believe these are all divisible by 16 and might as well divide by negative 16. So let's divide both sides by negative 16. I get t squared minus 4t minus 5 equals 0. This is easy factoring. This will factor t minus 5, t plus 1 equals 0. So t has to be either 5 or t has to be negative 1. But what's t? Yes, it's a time. So t cannot be negative 1. So t has to be 5 seconds. So now you can find the velocity when it hits the ground. It hits the ground when it's 5 seconds. So therefore, v sub 5 is equal to, what is your velocity function? Right here. So you're going to use that. Negative 32 times t equal 5 plus 64, which is negative 96 feet per second. Now, find the maximum height the object reaches. When do you get the maximum? Remember, our second derivative is negative. So this is concave down. So you will have a maximum when v sub t equals 0. So we're going to find when the v sub t equals 0, since that's the derivative of s sub t. And that's going to be equal to negative 32t plus 64 equals 0. So then that means negative 32t equal negative 64. Divide both sides by negative 32. I get t equal 2. So when t equal 2 seconds, your object reaches the maximum height. So now they said to find the maximum height. So you need to plug this 2 to position function, since s sub t gives you height of object. So you need to plug this 2 to s sub t to find the maximum height. So I need to find the s of 2, and given s of t right here, let's plug 2 in there. Negative 16 times 2 square plus 64 times 2 plus 80, which is equal to, if you use your calculator, you're gonna get 144 feet. And you found the maximum height. And let's solve another application problem involving growth rate. And this is again same as solving differential equation. The number of bacteria in a culture grows at a rate of dB dt equal 1 over radical t plus 1. Suppose the initial number of bacteria was 75. Find the number of bacteria after 9 days. You got it? So they gave us dB dt, and we want to find out b function, and b function gives you the number of bacteria, b sub t. So I need to find b sub t given b prime of t, which is dB dt, and they gave you initial number of bacteria, which is b sub 0, and they said it is 75. Very easy, right? And final question is not just to get the b sub t, but they said find the number of bacteria after 9 days. So they want you to find b sub 9. So I need to get b sub t first, so I can actually plug 9 in there. Get it? Okay, so how do I get b sub t? I will get b sub t if I take the integral of b prime of t, which is 1 over square root of t plus 1. And I would like to rewrite this so that it's easier to take the integral of. 1 over square root of t is same as t to the negative 1/2 power plus 1 dt. Then this is equal to, when I add 1 power, I get positive 1/2 power. Since my power become fraction, I'm going to multiply by its reciprocal instead of dividing and making a complex fraction. So that will be 2 times t to the 1/2 power. So 1/2 and 2 are reciprocals to each other. Plus, integral of 1 dt is just t plus c. Very easy, huh? So then, what do I have to do? I have to find c. How do you find the c? You get it from initial condition. So let's find the b sub 0. Let's plug 0 for t. So I get 2 times square root of 0 plus c is equal to 75. Well, that's 0, that's 0. So c is 75. So then my number of bacteria function is, it was right here. And then I just have to substitute 75 for c. So I get 2 radical t plus 75, and I found my number of bacteria function. So then, what would be number of bacteria after 9 days? that will be b sub 9, which is equal to 2 times the square root of 9 plus 9 plus 75, which is equal to 90 bacteria. Alright guys, this is everything for section 4.1. So 4.1 was pretty easy, huh? Study hard again and don't get behind, hanging in there.